Welcome, good afternoon, students, and welcome to our Maths Csec class for 2023. We are continuing where we left off last time with regards to addition and subtraction of fractions. Last class, just a quick recap. We started our topic on fractions. We did different types of fractions. So we have equivalent fractions. We also had mixed numbers and improper fractions. We basically learned how to convert a mixed number to an improper fraction and an improper fraction to a mixed number, right? So these are just the examples here with the steps. And we started addition and subtraction of fractions, right? So we are just gonna continue with that today's class. As before, what we're gonna be doing is that I'm gonna write down the notes on the slide and then you guys are gonna follow along. Afterwards, I will explain the notes and we will go forward. This will be the new normal where class is concerned. So today we are going to look at continuing. We are going to be continuing with addition and subtraction of fractions. Last time we dealt with fractions that has the same denominator and fractions that has related or denominators, right? Now we see here that fractions can only be added or subtracted if their denominators are the same. When this is so, we can simply add or subtract the numerators. So we cannot add or subtract fractions with different denominators. And we saw here what to do when you had different denominators or related denominators. Today we are going to look at what to do when we have completely different denominators. All right? So I'm just going to write down the notes and afterwards I will continue to explain. Okay, so let's take a look at this example here, right? And the next one, you will actually try it on your own because we do have another one. What we did here is simple. And the first exam, in the first, in this section here, what we did was to convert each fraction to have one common denominator. And we did this by finding the lowest common multiple of both denominators and then using that as one, right? So that was the first thing we did. Now, how we could do this is that we have 2 7s plus a half. So we could have done it individually like we did here. And the lowest common multiple of 7 and 2 is 14. So when we find the lowest common multiple of 7 and 2 being 14, what we have is that 7 divided into 14 will give us 2. And then 2 multiplied by 1 will give us, 7 divided into 14 will give us 2. And then 2 multiplied by 2 will give us 4. So this will give us our next step. To be able to convert, to find the equivalent fraction of the LCM of both denominators, we divide this denominator by the LCM. And then step 3, the result from step 2, we multiply that answer to the numerator of the fraction that we are converting. In this example, so I'm just come back to this. In this example, the LCM of 2 and 7 is 14. Therefore, divide 14. Therefore, so it would be, sorry about that. So let me just bring this a little closer here. Bring this a little closer here. This a little closer here. Perfect, right? So therefore now we would have an equation like this. It would be 14 divided by 7 is equal to 2. Right? From step 2, we our calculation would be 2 multiplied by 2 will give us 2 multiplied by 2 will give us 4. And this 4 will give us our numerator. So the new fraction becomes 4 divided by 14. Let me just add a note here so that you can take this down. Okay. The of 2 and 7 is 14. Therefore, that will be the right? So let me go through this one more time before I go a step further. What we're first going to do is we're going to convert each fraction to have one common denominator. In this case, it is going to be 14. And how we do this is by finding the LCM of both denominators and then using that as one denominator. Right? Now, the LCM of 2 and 7, as we see here, is 14. So that will be our new denominator that we will use to find the equivalent fraction of both, because that is basically what we're doing here. We are finding the equivalent fraction of 2 over 7 and 1 over 2 that has the same denominators. Because remember, fractions can only be added or subtracted if the denominators are the same. So we must always have the same denominator, and that is why we're going through this whole long process. Now in step 2, to be able to find the equivalent fraction of the LCM of both the numerator, not the equivalent, the numerator of the to be able to find the numerator of the equivalent fraction with the LCM from step 1. We divide the LCM, so not the first denominator, we divide the LCM by of the original fraction, right? So in step 2, to be able to find the numerator of the equivalent fraction with the LCM from step 1, we divide the LCM by the denominator of the original fraction. So the LCM here in this case is 40, right? And the original fraction, the denominator here is 2. So we're going to be, or in this example, let's look at 2 sevens. So we're going to be dividing 14 divided by 7, which gives us this 2 here, right? And step 3, the results from step 2, which is the 2 we got here, we multiply that answer to the numerator of the fraction that we are converting. In this case, 2 over 7. So we're going to multiply it by 2, which gives us 4. This 4 will give us our numerator. So the new fraction becomes 4 over 40. Any questions?
No, miss.
Cameron?
No, miss.
Okay, great. So let me just, yeah. And then our last step, this is what we are going to do. So in our last step, we simply add or subtract the numerators and find our answer. Remember to always reduce the final answer to the lowest fraction possible. Always remember that, right? Anybody have any questions? So let me go through it now using the example. We had 2 7s plus a half, and when we converted it using this method, we got 4 over 14 plus 7 over 14. Because the equivalent of a half is 7 over 14, and the equivalent of 2 7s is 4 over 14. So then we get 4 over 14 plus 7 over 14. 4 plus 7 is 11. We get 11 over 14. Can this be broken down simpler without leaving any remainders? No, it cannot, so it remains as is. There's another way to do it, which is this way that you are seeing here. And this way that you are seeing here, 2 over 7 plus 1 over 2, we simply, instead of making it 2 separate fractions, because it has the same denominators, we simply put one denominator, and as usual, we add the numerator and we get 11 over 40. Any questions? Everybody understands this?
Yes.
Okay, so what we have is an example, another example here, but you guys will be doing this one instead, and one of you will be telling me. I will give, are both of you all on computers, by the way?
Yes, miss.
Yes.
Okay, great. So for this example, what I'm going to be doing is that you are the ones that are going to be telling me what to do, and I'll give you remote control of the computer. I will open up the screen so you will have access. So you will be explaining the answer to the other students. Right? So this is what you are going to be working with. Oh, we have 10 minutes left. So that means you have 10 minutes to do this question. As soon as the meeting cuts off, you are going to log back in, and it will be time to correct. Please don't make me have to select somebody to do the question. I would rather you guys volunteer. It's okay to make mistakes, right? So you have 10 minutes to do this. And when the meeting cuts off, we will resume with the correction of it. So I'm gonna stay on the line, and I'm gonna stop here for now in terms of recording and resume when we restart.